All right, in section 5.5, we talk about inverse trigonometric functions and their graphs. So in 5.4, you learn the graphs of tangent. You also learn the graphs of cotangent, secant, and cosecant. Okay, and now what we're going to do is learn inverse trigonometric functions and their graphs. So let's start out with the definition. The inverse sine function is the function sine raised to the negative 1 with domain closed interval negative 1 to 1 and range closed interval negative pi halves to pi halves, defined by sine inverse of x equals y if and only if sine of y equals x. Again, this is read as sine inverse of x equals y if and only sine inverse of x equals y if and only if sine of y is equal to x. The inverse sine function is also called arc sine, and it's denoted by y is arc sine. Okay? Or you can just put arc sine there without the e. That's the notation we typically use. Again, we use sine inverse or arc sine. Okay, remember we talked about inverse functions a long time ago, and in order for you to, if you were given a function, in order for that function to have an inverse, that inverse along with the original function had to be 1 to 1. Well, you know, trigonometric functions in general are not 1 to 1, which is why in this case we restrict the domains on it. Okay, so if you pay attention here, notice that we've graphed sine x restricted to x equals negative pi halves to pi halves. So we restricted that. So this is the graph of sine x with those restrictions. And to find the inverse, we take that reflected across the line y equals x, and this is the graph. This across the line y equals x, and this is what you get. So that's the graph of y equals sine inverse of x. Okay? Now there are cancellation properties that also hold for inverse sine functions or for the inverse sine function, and these are those cancellation properties. You have sine of sine inverse of x is equal to x, where x belongs to negative 1 and 1. Sine inverse of sine of x is equal to x for x between negative pi halves and pi halves. These conditions are very important in order for cancellation to work. Whenever you have sine of sine inverse of x, in order for that to be equal to x, notice that x has to belong to the domain of sine inverse. The domain of sine inverse is negative 1 to 1. For sine inverse of sine of x to be equal to x, x has to belong to the domain of the restricted sign, which is negative pi halves to pi halves. What questions do you have? Okay, so now you need to remember all of this information. Notation, know the properties here, know the domain and range, because now we're going to look through some examples here. So, example 1. Example 1, we want to find the exact value of each expression if it is defined. Okay, well, we want to find out what's sine inverse of negative 1. Well, now we want the number in the interval negative pi halves to pi halves whose sine is negative 1. What is the number in the interval negative pi halves to pi halves whose sine is negative 1? You want the sine to be negative 1? You said 0. Remember that if you graph this, 0 is here. That point is 1, 0. You want the number in the interval negative pi halves to pi halves whose sign is -1? What is that? Remember I asked you, or I told you that you would definitely need to know the unit circle? It's high time for that.
Pi?
No, that's not in negative pi halves to pi halves. You have to be in negative pi halves to pi halves. Negative pi halves to pi halves.
Negative pi halves.
Negative pi halves. Very good. Negative pi halves. Right? Because this point here, you have a 0, -1, which means sine is -1. Remember, sine is your y value. What do you have next week? A test. That test is going to cover all of chapter 5 and possibly 6.1. Yes?
When did you say our quiz was again?
I say your test is next week. I didn't mention a quiz.
Okay.
You have a group work application that was supposed to happen last Wednesday, but remember we had a speaker last Wednesday. So your group work application, I'm going to pause this video. Here, now we want to find sine inverse of square root 2 over 2. We want to find sine inverse of square root 2 over 2. This is the number. So we're looking for the number in the interval negative pi halves to pi halves whose sign is square root 2 over 2. What is that? Yes?
Would that be pi over 4?
Yes, it is. That's pi over 4. Good. What questions do you have? Okay. Sine inverse of -2. What is it? Is it defined?
No.
Why?
The range is -1
Because it's not, the range of sine is -1 to 1, but the range of sine is the domain of sine inverse. So you're thinking about it correctly. Just remember to switch. You know the range of sine is -1 to 1, but the domain of sine inverse is -1 to 1. We know -2 does not belong to that domain, so this is undefined. Very good. So since -2 is less than -1, it is not in the domain of sine inverse of x. So sine inverse of -2 is not defined. So the answer here is undefined. Okay? Example 2. Example 2. Example 2, we want to find the exact value of the expression if it is defined. So we have sine of sine inverse of -3/4. What is this? -3/4. Why is it equal to -3/4?
That's the cancellation property.
The cancellation properties. What do you have to make sure holds here?
That's the in between the intervals -1 to 1.
Good. So -3/4, remember this notation, belongs to the interval -1 to 1. So we can use the cancellation properties from page 1. So good. -3/4. What's sine inverse of sine of 5 pi over 6? You want it? Go for it.
Is it undefined?
No? Why do you think it's undefined?
I thought, 5 pi over 6 would not fit between, negative, pi over 2 and pi over 2.
That is correct. That part is correct. 5 pi over 6 does not belong to negative pi over 2 to pi over 2. Because that doesn't belong there, that means we cannot use the cancellation properties. However, we can still do this problem because we can find sine of 5 pi over 6 and then evaluate it that way. So this would be equal to sine inverse of what is sine of 5 pi over 6? What is sine of 5 pi over 6?
Square root of 2/2.
Nope. That's only for angles ending with a denominator of 4.
Would it be negative root 3/2?
No. You all need to learn your unit circle. We went over it in class. Bring it up, look at it.
1/2.
It's 1/2. Good. Sine of 5 pi over 6 is 1/2. So we have this as sine inverse of 1/2. So now we want the number in the closed interval negative pi halves to pi halves whose sine is 1/2. What's the number in the interval negative pi halves to pi halves whose sine is 1/2?
Would it be pi over 3?
Nope.
Pi over 4.
No.
Pi over 6.
Pi over 6. Good.
Oh,
Pi over 6. So one thing to note here, and I'm not going to write it, you write it if you want to. We stated it at the beginning of part B. We can only use cancellation here if 5 pi over 6 actually belong to the closed interval negative pi halves to pi halves. Okay, but it does not. And since it does not, that means we have to go through, find sine of 5 pi over 6, and then find sine inverse of whatever that is, which in this case it happened to be 1/2. Okay? What questions do you have? Silence. Does that mean none?
none right now.
Okay, all right. Example 3, calculator problem. Use a calculator to find an approximate value correct to 5 decimal places. So what you want to make sure you do here, you want to make sure your calculator is in radian mode. Make sure your calculator is in radian mode, and then find sine inverse of -8/9. So I'll give you 1 minute to do that. All right, so what did you get?
Negative 1.09.
Talk louder, please.
Negative 1.0949.
-1.0949. 5 decimal places? 1. Good. That's your answer. You just have to make sure your calculators are in radian mode here. Okay? Good. Now let's talk about another inverse trigonometric function. What does it look like? We're going to talk about here. Good. The inverse cosine function. The inverse cosine function. Thank you. The inverse cosine function is the function cosine raised to the -1 with domain -1 to 1 and range 0 to pi, defined by cosine inverse of x equals y, if and only if cosine of y equals x. The inverse cosine function is also called arc cosine. It's also called arc cosine, denoted by arc cos, like that. Okay? So again, the inverse cosine function is the function cosine inverse that has domain -1 to 1, range 0 to pi, and is defined by cosine inverse of x equals y, if and only if cosine of y equals x. Okay? Notice that again, trigonometric functions aren't one-to-one, so we have to restrict the domain of cosine of x in this way. We restrict it to 0 to pi, and notice that the range is from negative 1 to 1. Okay? So then you take this restriction and you flip it or reflect it about the line y equals x. Reflect that about the line y equals x. Then you get this. This is the graph of y equals cosine inverse of x. Notice that the domain is from negative 1 to 1. The range is from 0 to pi. Okay? We also have cancellation properties. Your cancellation properties are as follows. Cosine of cosine inverse of x is equal to x whenever x is between negative 1 and 1. So x has to make sense in cosine inverse of x for you to use the cancellation properties. Okay? Which means x has to be in the domain of cosine inverse. Cosine inverse of cosine of x equals x for x between 0 and pi. That's the restricted cosine domain. Okay? So, use a calculator in example 4. Use a calculator to find an approximate value correct to 5 decimal places of cosine inverse of 4/9. Cosine inverse of 4/9. I will give you 1 minute. Okay, what are you getting?
1.1104.
Good. Good. What questions do you have? Okay, so let's go through an example where we actually find the exact value of given inverse cosine functions. So we have cosine inverse of square root 2 over 2. I could have written arc cosine of square root 2 over 2. That would have asked you to find the same thing, right? Just because some are trying to picture it. You could have written this as arc cosine of square root 2 over 2. It's the same question. Okay? Now, here, we're looking for the number where? In what interval?
Negative 5/2 to pi.
No.
0 to pi.
0 to pi. Good. We switched to functions. We're not looking at sine inverse anymore. So we're looking for the number in 0 to pi whose cosine is square root 2 over 2. So now you're looking 0 to pi. You're looking for the number whose cosine is square root 2 over 2. What is that? Pi over 4. Good. That is pi over 4. Cosine inverse of 1. Bless you. Cosine inverse of 1. We're looking for the number in 0 to pi whose cosine is 1. What is that? 0. Good. That's equal to 0. So that is 0. Yes?
Is that because of the cancellation rule?
Mm.
If it's in,
That's not because of the cancellation rule. That's going back to knowing the corresponding points that correspond to your angles.
okay.
So whenever you have 0 to pi, the point at 0 is 1, 0. So remember that the cosine is the same thing as your x. So cosine is 1 at 0. So you're only thinking of the cancellation properties and things like this. Up here, you have to remember what your domain and your range is, because that's the guiding force with finding the exact value for individual, like not individual, for finding the exact value of the inverse cosine of a number or of an angle.
Okay, thank you.
You're welcome. What other questions do you have? Good question. Okay. Part C. Cosine inverse of negative square root 2 over 2. We want the number where? But in the closed interval 0 and pi. Who's what?
Whose cosine is,
Negative square root 2 over 2. And what is that?
is that one fine?
No?
3 pi over 4.
What did you say?
3 pi over 4.
Good. It is 3 pi over 4. It's 3 pi over 4. Remember that if you're going from 0 to pi, you have pi over 4, 2 pi over 4, 3 pi over 4. At 3 pi over 4, remember, your cosine is negative and your sine is positive. Your cosine is negative square root 2 over 2. Okay? This should reiterate how important knowing the unit circle is. You won't always have that sheet there. I highly suggest that's something that you put on your to-do list for this evening to memorize and have it memorized by the time you have class on Wednesday. Okay? All right. Example 6. Find each value if it is defined. Cosine of cosine inverse of 2/3. What is that equal to?
2/3.
I'm sorry, what did you say?
2/3.
2/3. Good. Why is it 2/3?
Because 2/3 is between the interval -1 to 1.
Good. Since 2/3 belongs to the interval -1 to 1, we can use cancellation properties. So, in part B of example 6, we want to find cosine inverse of cosine of pi over 4. And note that pi over 4 belongs to the closed interval 0 to pi. That is a pi here. Okay? Since pi over 4 belongs to that interval, we can use the cancellation properties. So we get cosine inverse of cosine of pi over 4 is equal to pi over 4. What questions do you have? Okay, now let's talk about another inverse trigonometric function. Let's look at a definition. Guess what we're going to talk about here? Can't hear you? The inverse tangent function. Good. The inverse tangent function is the function tangent raised to the -1 with domain, what is this? All real numbers, and range negative pi halves to pi halves. Notice that negative pi halves and pi halves are not included here, okay? Because at negative pi halves and at pi halves, what exists for tangent? Vertical asymptotes. Good. This was in 5.4. Okay. Good. So notice that the inverse tangent function is tangent inverse, has domain R, all real numbers, range negative pi halves to pi halves, is defined by tangent inverse of x equals y, if and only if tangent of y equals x. The inverse tangent function is also called what? Arctangent, good. It's called arctangent. And denoted by arctan. So notice that, again, we have to restrict tangent of x to negative pi halves. The pi halves, notice that they're vertical asymptotes here. And this is at negative pi halves and pi halves here. And so that's the restricted tangent function. So then you find the inverse of that. The inverse is this function, which is tangent inverse of x. Notice that the domain is now negative 1 to 1, and the range is negative pi halves to pi halves. Okay? You have the cancellation properties for tangent as well. So tangent of tangent inverse of x equals x for all real numbers x. Tangent inverse of tangent of x is equal to x for x between negative pi halves and pi halves. Okay? You'll need to know these. I suggest that you go through and create a sheet where you write the fundamental identities that you've learned for your trigonometric functions. Write down the unit circle. Make sure you know it. Make sure you know these cancellation properties. Make sure you know the domains and ranges, because all of this information is going to be put together, and you're going to have to be able to find exact values. You're going to have to be able to identify what cosine is, what tangent is, what sine is, what secant is, what cosecant is, and what cotangent is. And then you'll have to be able to apply this information to other things. So you have to make sure your foundation is strong by knowing those basic things. Okay? All right. So now let's find each value. Let's find each value. Let's find the value of tangent inverse of 0. So here, we want the number. Where?
Would it be the interval negative infinity?
No. It's not in the interval negative infinity to infinity. Because remember, whenever you're trying to find tangent inverse of 0, you want to find a number whose tangent is 0. So because you want to find a number whose tangent is 0, what interval are you in?
Negative pi over 2 to pi over 2.
Negative pi over 2 to pi over 2. That's good. So the number in negative pi over 2 to pi over 2, notice that we're not including those, whose tangent is 0. So what's the number? So now we're going from negative pi over 2 to pi over 2. We want the number whose tangent is 0. Whose tangent is 0?
Is that 0?
0. Good. 0. Okay, because you have the point 1, 0. So tangent is sine of x over cosine of x, so that would be equal to 0 over 1, which is 0. Good, so that's equal to 0. Tangent inverse of negative square root 3. So we want the number where?
Negative pi over 2 to pi over 2.
Good. From negative pi over 2 to pi over 2. Who's what?
Tangent is negative square root 3.
Good. With tangent, negative square root 3. So remember, tangent of x is equal to sine of x over cosine of x. what does x have to be in order for you to end up with negative square root 3? What do you mean greater than 0? It has to be in between negative pi halves and pi halves. Now this is really boiling down to, do you know the unit circle? Okay, so the x that we're looking for here needs to have, I'm gonna move this up and do some scratch work below. So the x that we're looking for here needs to have sine of x equal to square root 3 over 2, and cosine of x needs to be negative 1/2. We know that we have to be in the interval negative pi halves to pi halves. Well, we know tangent is negative, so it cannot be in quadrant 1, it has to be in quadrant 4. So we're looking for the angle. Notice that cosine is positive here, or notice that cosine is what? Is positive here, right?
Yeah.
And sine is what? Negative. So we need to write negative square root 3 over positive 1/2. So that's equal to negative square root 3 over 2 times 2 over 1. That cancels, gives us negative square root 3. What angle has cosine of x equal to 1/2, sine of x equal to negative square root 3 over 2 in that interval?
5 pi over 3.
In that interval, negative pi halves to pi halves.
Negative pi over 6.
No,
Is it 11 pi over 6?
no. 11 pi over 6 is not in the interval negative pi over 2 to pi over 2.
Should be under 5.
No. You're looking for the angle whose cosine of x is equal to 1/2. Sine of x is equal to negative square root 3 over 2.
Why wouldn't it be 5 pi over 3?
5 pi over 3 is not in the interval negative pi halves to pi halves.
Isn't so negative half is, that's like 0, comma negative 1, right? That's negative pi halves.
The point for negative pi halves is 0, negative 1. For negative pi halves,
Right.
for pi halves is 0, 1. For this point 0, it is 1, 0. And you said 5 pi over 3, but 5 pi over 3 is not there. We're going from negative pi halves to pi halves.
Is it, negative pi over 3?
Negative pi over 3. It's negative pi over 3. Good. It's negative pi over 3.
Oh, okay.
So you're thinking of the right position, but remember, you have to take that and subtract 2 pi from it.
Oh, okay.
Because you have to go, it's in quadrant 4, so you have to go back and, it's the reference angle
Okay.
bit. Does that make sense?
Yeah.
Okay. So you have negative pi over 3 here. See, tangent inverse of negative square root 3 over 3 is what?
Pi over 6.
I can't hear you. Say it louder, please.
Negative pi over 6.
Very good. It's negative pi over 6. Notice that we want the number in the open interval negative pi halves to pi halves with tangent negative square root 3 over 3. And that is, in fact, negative pi over 6. Because in this case, you have tangent of x. Remember, it's sine of x over cosine of x. And we really want it to be 1/2, negative 1/2, divided by square root 3 over 2. And the angle in negative pi halves to pi halves with those properties is in fact negative pi over 6. So notice that this is what we get. The 2's cancel. That's negative 1 over square root 3. And then you'd have to rationalize it, which means you multiply by square root 3 over square root 3. We went over these in a previous section. And doing so gives you negative square root 3 over 3, which is exactly this. Other things to note: inverse secant, inverse cosecant, and inverse cotangent. The graphs are located on page 444 of your books. Make sure you go through those. It's on page 444 of your books. The graphs are there. Okay? What questions do you have?
None right,
Can't hear you?
none right now.
Okay. All right. Let's move on. This was section 5.5.